First of all, now I think you have seen parabolas in high school and in lycée, and the most familiar parabola, or the most famous parabola, is I think y equals x squared. So let us start with that conic. First example. We'll consider the parabola y equals x squared. Find focus, directrix, and latus rectum of y equals x squared. Now we know that a canonical equation of parabola is either y equals 1 over 4f x squared, or y is equal to minus 1 over 4f x squared, or you can interchange rows of x and y to get x equals 1 over 4 fy squared, etc. And we know that such an equation arises if we choose. Now, if we choose the axis of parabola as x-axis, the resulting formula will be y equals something x squared. X equals something y squared. And if focus is chosen on the y-axis, or if we choose axis of parabola as the y-axis, then the resulting curve will be equal to y equals 1 over 4f x squared, or minus 1 over 4f x squared. If we choose focus on the positive part of y-axis, then, of course, here positive y-axis means positive part of y-axis is of the form y equals 1 over 4f x squared. Now here in this equation, if we take the coefficient, now we wish to set this coefficient to be equal to 1, but this means that 4f has to be equal to 1, which means that f has to be chosen as 1 over 4. Then this equation gives the equation we are given. We have started with y equals x squared. So focus of the parabola y equals x squared is at the point. Now it will be on y-axis, so the first coordinate will be equal to 0, and second coordinate here, f, this f, is the focal length. So f 1 over 4. Now to find equation of directrix, directrix is perpendicular to axis, and it passes through the point which is symmetric of focus with respect to the origin. So directrix for y equals x squared is the line, straight line, y equals minus 1 over 4. Okay, and length of the latus rectum is, we have seen the last time, to be equal to 4f, so it is equal to 1. So we have, burası çıkmamış, length of, şurayı sileyim yine baştan yazayım. Okay. We need here length of length of the latus rectum is 4f, which is equal to 1 in this question. Okay. Now, in the next example, we will obtain equation of a parabola when its directrix and focus are given. Second example. Example 2. Write an equation of the parabola with directrix x plus 2y minus 3 equals 0 and focus at the point 3 and 5. Nice. Now we will try to obtain equation of the parabola whose directrix is a given line. Now there is no need to sketch a graph of the situation. We can obtain immediate equation of the parabola just by certain computations. Now, for any point, now recall that definition of parabola with directrix some line and focus at some point is the locus of points whose distance to that line and to that point are the same. So we start with writing distance of an arbitrary point, say x, x0, y0, on the parabola. In fact, this equation is for any point. It needs not to be on the parabola. Xd squared is equal to x0 plus 2y0 minus 3 squared divided by 5. 5 is sum of squares of coefficients, variables. X0 has coefficient 1, y0 has coefficient 4. The sum of squares is equal to 5. Okay. And the distance squared to focus is equal to x0 minus 3 squared plus y0 minus 5 squared, so that now these quantities should be equal. These distances or squares of these distances must be equal, which gives us x0 squared plus 4y0 squared plus 9 plus 4x0y0 minus 6x0 minus 12y0 is equal to 5x0 squared minus 6x0 plus 9y0 squared, okay, 10y0 plus 25. Now, if we simplify this one, we will obtain, of course, a much more reasonable equation in terms of x0 and y0. But x0, y0 is for any point, an arbitrary point on the parabola. Hence, we can take, instead of x0, y0, the generic case, namely 4x squared minus 4xy plus y squared minus 24x plus 45, no, plus, I'm sorry, minus 38, 24 x0 minus 38 y0 plus 116 equals 0. Doğru mu? Sanki hata var gibi geliyor. Eksi 50'ye 0. 12 yerde 38. Eksi 0. Eksi 36 geliyor. Doğru gözüküyor. Okay. This is equation of the parabola with given directrix and focus. Now let's solve another example.
Hocam,
Efendim?
eksi 28 x0 olmayacak mı? Ya yanlış mı bakıyorum? Tam emin olamadım. Eksi
Ben de bir şeyden şüphelendim ama bir dakika. Eksi 30
28.
var. Doğru mu?
Evet. Sol tarafta artı 4 x0 ile eksi 6 x0 var. Ya eksi 2 x0 oluyor sol tarafta da. Oraya artı diye attım. Eksi 28
Hayır.
oluyor.
Burada bir tane eksi 0 var. Eksi
tane
6 x0 var.
Bir tane daha var ya hocam solda.
Nerede?
Tamam, tamam çarpmamış. Tamam. Teşekkür ederim.
Şu anda hala 24 değil mi?
Evet tamam.
Evet. Herhalde doğru canım. Siz kontrol edersiniz. İşlem hatası varsa düzeltirsiniz. Okay. Next. Say that. Okay. Example 3. Find an equation. So here we will give some properties of a parabola and we will try to find its directrix. Find an equation of the directrix D of the parabola whose now what are we given? We are given the focus of the parabola. It is at f 3, 1 and vertex is at 0.73. So we are given a focus and vertex. Now, what do we know about the parabola? We know that vertex is the midpoint of the line segment GF. Now, what is G? Here, I am not going to define G. We know that G is the, okay, let me here write as a note, but this is our standard notation. G is the intersection of the axis and directrix. Okay. And for the parabola, if this is directrix and focus, the line perpendicular to directrix and passing through focus is axis, and this point is G, and vertex passes through this point, through the midpoint. Now, since vertex is the midpoint, we can obtain coordinates of G immediately. Okay, it follows that the axis intersects directrix at point. Okay, now we will find a point so that 7, 3 is midpoint between midpoint F and this point. So 3, 7, so the first coordinate should be 11, and the next coordinate difference to 5. So we found the point of intersection of axis and directrix. In particular, we found a point on the directrix. Now, if we can find slope of directrix, then we can write this equation immediately in plane. Now, on the other hand, we know that F and V are both on the axis. Now, slope of a vertical line is equal to the ratio of differences of second coordinates to first coordinates of any 2 points on it. So, in particular here, we can write slope of the axis as the ratio of differences of 2 points it contains. Now, 3 minus 1 divided by 7 minus 3 will be equal to, okay, is 3 minus 1 divided by 7 minus 4. Okay, and this is equal to what? 2 over 4, 1 over 2. This is a slope of the axis, but D is perpendicular to the axis. And we know that if two lines are perpendicular to each other, or if they are perpendicular, then product of their slopes is equal to -1. So slope of D is -2. Then we know slope and coordinates of a point on directrix. Then we can write its equation immediately as y equals -2 x minus 5 plus 11, or simplified, y equals 21 minus 2x. Okay, so we have seen 3 examples about obtaining equation or deriving some information about the parabola. Now it's turn for ellipse. Are you okay up to here? Any questions about parabola? Okay.
Hocam ben bir şey sorabilir miyim?
Evet.
G noktasını bulurken niye ekledik? Neden çıkarmadık?
Efendim?
G noktasını bulurken niye ekledik de çıkarmadık?
Şimdi G,
Normalde sizin çizdiğiniz o küçük çizgide Fallowstat'in oradaki halde G ve F yan yana, G geride kalıyor.
V burada, G de burada.
Evet.
Tamam mı?
Ha öyle mi? Tamam, ben sizin çizdiğinizde G geride sandım. Pardon, tamam.
Bakayım, yok orada da. İşte F, V ve G. Yani G burası.
Tamam. Teşekkür ederim.
Tamam. Gözden kaçmış o. Peki. Şimdi elipsin denklemine. Bu ne yüzü olmuyor? Allah Allah. Ya 94 diye 106 oluyor. Tamam, şöyle olsun. Perpendiküler niye oluyor ya? Çok komik. Ya şurada doğrudan doğruya bazı algıladığı şekilleri otomatik çizmeye çalışıyor. Onları kapatayım da. 4 yazıyorum, üçgen yapıyor. Şurada da A'yı üçgen yapmış. Demek ki benim A harfim A'dan çok üçgene benziyor. Peki. Canonical equation of ellipse. The next title. Biraz daha şunu atayım. Şu. Pardon. Bir ayar bozuldu. Oturtmaya çalışıyorum. Okay. Canonical equation of ellipse. Now, given an ellipse with directrix D and focus F. Focus F. Of course, in a parabola, for a parabola, directrix and focus, this pair is sufficient. But for the ellipse, we need three parameters. Directrix should be given, focus should be given, and as well eccentricity must be given. Otherwise, we cannot talk about a unique ellipse. So we should have given a focus, directrix, and as well and eccentricity. Some positive real number less than 1, okay, for ellipse. Now, to obtain equation, first we define some certain points and we will compute certain quantities. We first choose, we first consider the center and recall that the center of an ellipse is midpoint of two vertices. Again, recall that parabola has one vertex, other conics, ellipse and hyperbola, has two vertices on the axis. And midpoint of two vertices is called center. Okay, now we call the distance between center to focus F. Now we will first compute the quantities, namely this distance of center to point G and the distance between center and V1. Of course, this is as well equal to CV2 because C is midpoint of V1, V2. Now we will first compute these distances in terms of D and E. Now we state a property. Now this property is important. We will use it frequently. Okay. Our property. If the distance from center to focus is F, then CV1 is equal to CV2 is equal to F divided by E, and the distance between C and directrix, the center and directrix, is F over E squared. Now we will prove this. Okay, proof. Now let us give names to the quantities, distances we are trying to find. FC1, the distance between C and V1, şurasını düzelteyim, çirkin gözüktü. C1, this distance. C, V2, call this as V, and the distance between center and directrix as U. Now we have a figure. Say that this is axis and directrix. G. Now assume that we have vertices here and here. These are points which belong to ellipse. This is a focus, and say that this is the center. Okay. So focus, center, V2, V1. Now call this distance, and this distance, we call these distances V. And the distance between directrix and center, U. Okay. And our basis is the distance between center and F, focus, and we have called this distance as F. Okay. Now, from the figure, we can write the following. Now, first of all, V1 and V2 are the red points, are on the ellipse. So they have to satisfy the condition for a point to be on the ellipse. What is this condition? The condition now V1 is on the ellipse, so its distance to focus is E times its distance to G. Now this condition can be read as now V1F, the distance from V1 to F is V minus F. Now this must be equal to E times V1G. Now the distance from V1 to G is, okay, U minus V. And on the other hand, second vertex is also on the ellipse, so it must satisfy the relation which gives in a similar manner. Now V2F, you can check that V2F is F plus V, and this is equal to E times now U plus V. Okay, now we can combine these equations to solve what V and U, combining these equations. We obtain V equals CV by definition, and this is equal to F over E, and U CG is equal to F over E squared. Now these quantities are very important. We will use them frequently. Now let us return back to this figure we have drawn over there. Then if you set the distance from center to focus to be F, if you let this one to be equal to F, then this distance, the distance between center and directrix is F over E squared, and the distance between center and vertices, F over E. V is equal to F over E, and U is equal to F over E squared. Nice. Now we can use these quantities in obtaining a nice equation, canonical equation of the ellipse. Now to do so, let me return back to the figure. Now, what are the reasonable candidates for coordinate axis? Of course, axis seems quite reasonable because axis of the ellipse, I mean. It contains two vertices, focus and center. Many important points are located on the axis. So it is quite reasonable to choose axis as one of the coordinate axes. We can choose the axis as x-axis. Then y-axis can be any vertical line, but to make a meaningful choice, we can choose it to be the directrix or a line passing through one of the vertices or focus or center. But to obtain some symmetry, you see that center is located to be the midpoint of V1 and V2. And we are going to take a y-axis to pass through the center. So our choice will be this one to be the x-axis and y-axis to pass through center. So we will have this coordinate system. And we will try to obtain canonical equation of ellipse in that coordinate system. Let us write these. We choose Cartesian coordinate system in plane so that the origin of that system is on the center of the ellipse, is on the center of the ellipse, and x-axis is coincident with the axis. Since we have chosen the origin and x-axis, y-axis is defined implicitly to be the line perpendicular to axis passing through the origin. Now, we first write coordinates of main points. Consider the figure, another figure. Now, this is our x-axis and y-axis. Directrix its intersection with axis G, and we have vertices of the ellipse. Bu biraz daha şöyle seçelim. Olmadı. Simetrik olacak. Okay. And say that we have the focus here. Nice. Now, we again call this distance to be f. This will be our most important parameter. And this point is C. This is V2. Later on, we will call this V1. And this is V1. And this is the focus of the ellipse. Now focus has coordinates minus f and 0, obviously. Now we have seen that the distance from C to V2, C to V2 is f over E. So this point has coordinates f over E0, and this one minus f over E0. And point G has coordinates minus f over E squared and 0. Now, given an arbitrary point X on the ellipse, we will be interested with the distance between this point and directrix, as well the distance between this point and the focus. X, say, has coordinates xy. Okay, we will refer to this figure. Now, the point X is on the ellipse. So, X, şunu biraz daha çıkaracağım. Tekrar indirin bakarken. Okay. X is on the ellipse. Implies that XF is equal to E times XD. Bu sınıfta yasak, tahtada yapamam bu hareketi. Okay. Now, what is XF? In coordinates of these points, XF, the distance between X and F is X plus F squared plus Y squared. Let us write it. Oh. Okay. Let me write here. XF is equal to, in fact, I am writing not XF, square of XF, X plus F squared plus Y squared. Now, this has to be equal to E squared times XG. But XG, the distance from the point X to G is X plus F over E squared. Squared once more. So, coordinates of any point on the ellipse must satisfy this relation. Conversely, if coordinates of some points satisfy the last equation we have written, then it is certainly a point on the ellipse. So, this is equation, this will lead us to the equation of the ellipse. Now, we have obtained some equation which simplifies into 1 minus E squared X squared. Now, when we expand this, we will have X squared minus X squared E squared will give us 1 minus E squared times X squared. Now, here we will have 2XF. And the second term here, XF over E squared times 2, but with this E squared will be cancelled and these terms will vanish. Then we will have here an F squared plus Y squared. And here we will have F squared over E to power 4 e to power 4 will be cancelled with this one to give us f squared e squared. So we will have f squared over e squared times 1 minus e squared. So above equation is equivalent to this one. Şurayı temizleyelim. Okay, now we have obtained equation of ellipse. Equation of ellipse is in this form. Now here we will, of course, we cannot further simplify this one, but we can obtain a reasonable, a simple equation if we give names to certain quantities. So we will put, okay, if we put A f over E and B to be equal to A times square root of 1 minus E squared. The equation takes the form the canonical equation of ellipse is then now what did we call? A is equal to f over E. Now in this equation, if you divide everything with the right hand side, namely f squared e squared times 1 minus e squared, here 1 minus e squared will be cancelled down, and we will have here x squared over f squared over e squared. But f squared e squared is already called A. So we will have on the right hand side x squared over a squared plus, now this term, check that f squared a squared e squared is a squared. So b is namely, if we divide everything with right hand side, it will be the denominator of y, the second term. So we will have y squared over b squared is equal to 1. So this is canonical equation of the ellipse. Here, for this ellipse, for this canonical equation, if we are given ellipse in this form, of course, it is evident that when y is equal to 0, x is equal to x squared is equal to a squared, then x is plus or minus a. Then minus a, 0, and a 0 are x-intercepts, or and vertices are the x-intercepts. In other words, the vertices of the ellipse. And when x equals 0, we obtain the points 0 minus b and 0b. These are the y-intercepts. Of the ellipse. Now, if we are given such an equation, if we are given an ellipse in terms of with canonical equation, how can we obtain focus, eccentricity, and other quantities? Now we see that if we are given the ellipse x squared over s squared plus y squared over b squared equals 1, then it is evident that vertices are at points minus a and a on the x-axis. And we can find this y-intercepts as well. But what about foci, focus, and what about the directrix, eccentricity, etc.? Now, when an ellipse, is given, with the above equation, canonical equation, other parameters, other, of course, not all important parameters, can be computed in terms of A and B as follows. First of all, eccentricity is equal to A squared minus B squared. You can obtain these relations immediately from the above equations. And distance between C and F is equal to F. And this is equal to, now we do not know F, we wish to compute F. We are given only A and B. Here we have computed E, eccentricity in terms of A and B. If you multiply A with eccentricity, you get the focal length. And the distance between directrix and center is equal to A over E. We know that this quantity is equal to, because F over E squared. Nice. Okay, any questions up to here? Okay, I think we have to stop here. We'll continue with some properties of ellipse later on. If you have any questions, you may ask. Hatta beni görün öyle sorun. Hatta recording'i de durdurayım. Any questions? Var mı sorunuz muhterem Cevat?
Bakabilir misiniz? İkinci example'a.
Efendim?
Example 2'ye bakabilir misiniz?
Bir saniye. Şunu açayım. Example 2. Yukarıda kaldı değil mi? Buralarda bir yerde. Evet.
Şimdi Sodet'ten sonra x sıfırın karesi artı 4y sıfırın karesi falan diye gidiyor. Ortalıkta hiç x ve y yokken biz aşağıda nasıl x kare falan bulabildik?
Ya onu aslında söyledim. Şimdi bu parabol üzerine bir nokta seçtim. Koordinatları x0, y0 olsun dedim. Ve o nokta için bu denklemin sağlanması gerektiğini gördüm. Ama o noktanın bu denklemi yazarken, elde ederken kullandığım tek özelliği parabol üzerinde olmaktı. O zaman şimdi bu parabol üzerindeki her x ve y koordinatlı nokta için geçerli olacağı için x0 ve y0 yerine x ve y yazabiliriz. Aslında söylediğim iyi oldu. Şurada delil bırakmışız. Şunları da sileyim. İyi oldu.
Evet, ben de onun için demiştim zaten. Onlar x0, bunlar x.
Ha, evet. Doğru, haklısın. Haklısın. Evet. Söylediğin iyi oldu. Onları da silmiş olduk. Teşekkürler. Evet. Başka sorusu olan var mı? Peki, o zaman dersimiz bitti.